Using anymore, so I'll start the class now. Are you able to see the screen?
Yes, sir.
Okay, so today it will be last lecture. I'll be covering Dvorak technique. It is a technique that is used to analyze satellite imagery and interpret it from the point of view of cyclone analysis. So whenever a cyclone is there and it is getting detected into your satellite image, this technique allows you to identify the patterns associated with the cyclone, what is the intensity of cyclone, what is the center of cyclone, etc. So analysis of tropical cyclones using satellite imagery is what this technique does. Okay. On the left hand side, you can see that this is the image of actual scientist Vernon Dvorak. He passed away in 2023. Just 2 years back, he passed away, and he devised this technique in the 70s and 80s. Okay, so it is roughly 50 years old technique. When the satellite images were available in the early days of satellite technology, whenever geostationary satellite was launched and the continuous images was available, continuous by continuous means at those times every 3 hourly or every 6 hourly, based on the satellite, the images were available every 3 or 6 hourly, not like 15 minutes or 10 minutes that we get nowadays. And sometimes there will be some missing images also. Also, the quality of images were not as high as currently available images. Okay, but still there were for the first time what happened in that era was, before that also and during that time, excess aircrafts available with the US Air Force or US Navy, they were diverted for some scientific applications, and the aircraft used to analyze using different sensing instruments what is the wind field associated in the different directions, or what is the wind speed and overall wind structure in that particular region where actually cyclone is present. Okay, so they used to carry different instruments which used to give them the wind field associated with tropical cyclone. Okay. But when satellite came into picture, the satellite images allowed what you can see on the right hand side, a picture of a tropical cyclone. Here there is no wind information, nothing else, simply the cloud structure and the associated clouding is available. Right. So what this scientist did was he tried to match the two things. He tried to analyze how the satellite imagery looks like, or how the cyclone appears in the satellite imagery when vis-a-vis how it appears in the actual ground aircraft. So, for example, just for analogy, I'm trying to tell you this. For example, if you fly an aircraft over this particular cyclone, and now you know with aircraft observations that okay, for this cyclone, the maximum wind speed is say 50 knots, for example. It would be much higher for this type of cyclone, let's say 80 knots or 120 100 knots. So whatever it is, the aircraft is confirming you that we considered as the actual wind speed, the best possible measurements, say 100 knots for this particular case. And now you also have the satellite imagery associated with it. So when the wind speed is 100 knots, how the cyclone appears in the satellite imagery. He tried to analyze this, and then he came up with this particular technique. So this is an empirical technique. This technique utilizes only the satellite images, and even in satellite images, only visible channel image and IR1 channel image. Okay, no satellite derived wind products or vorticity or convergence, divergence, nothing else is used. Only plain image like this, either visible or IR1. And by analyzing that, you will be knowing you will come to know what is the intensity associated with that particular image. Now, the same technique is utilized all over the world till date, even in USA, all the basins like Pacific, Atlantic, China, Japan, Australia, India, France, everyone is using the same technique. Okay. But over the North Indian Ocean or apart from Atlantic and Pacific, mostly over Atlantic, this study was done and it was devised over Atlantic region, and later on it got adopted by rest of the tropical cyclone monitoring centers. Till date, there is no such experiment carried out over North Indian Ocean or even the South Indian Ocean, but it is found that this technique with the actual ground-based data, ground-based radars, actual observations, and various satellite-based observation, it has been found that this technique performs very well. And whenever there is a highly accurate satellite measurement available over the region, it is found that this technique, whatever this technique is giving you intensity of that cyclone, actual observations are very close to the what is derived using this technology. Okay, so if the newer technology is available, then why to use this old technology? Okay, it is there are reasons for that. The new technology or the actual wind measurements are carried out using the polar satellites, and polar satellites does not give you continuous monitoring. Polar satellites will give you only whenever there is a pass, that time they will give you what is the wind speed in at the sea surface level. Also, this wind speed at sea surface level using polar satellites has a limitation that it can detect wind speed only up to 50 knots, but cyclone goes up to 120 knots, right? Or even more than that. So it cannot detect wind speed beyond 50 knots as of now. What about the actual radars or actual ground based observations where the wind speed is measured? Now, by the time cyclone comes close to the coastal observations, you need where it is going, you need to forecast it where it is going to hit. Okay, you cannot wait till the last moment and then say that okay, this is the wind speed that we are getting at the ground observation, so we are classifying this cyclone into a particular category. You have to do that in advance. So cyclones get developed inside, deep inside the oceans, like they get developed far away from the coastal region in the deep seas, and roughly it takes 4 to 5 days. The lifespan of cyclones varies between months and seasons as well as the basins. But roughly, what you can say is when a thunderstorm has a life scale or lifetime of say couple of hours or up to 3, 4, 5 hours, whereas the tropical cyclone has lifetime of 3 days, 4 days, or 5 days. Okay, so it is a slowly moving system. The circular wind speed associated with cyclone may be very high, but the translational speed, that is the movement of entire cyclone from one place to another, that is not of very far, that is not happening at those speed. It happens very slowly. Okay. So you have, when it is away from the coast, say the coastal radar will give you image up to 250 kilometers roughly, but whenever it is beyond 250 kilometers away from the radar, then you have nothing else but satellite imagery to analyze the cyclones. And that's where the satellite plays a very important role. Whenever cyclone formation is there, wherever genesis is occurring, what is the likely area where it is occurring, and then slowly when it starts to develop, how the intensity is changing, how much far away from the center of the cyclone the clouding can be seen, etc. All this information is done using or analyzed using this particular technique. That's why this particular technique is still being used. You would have seen this table, or you would have heard this names nomenclature like well marked low, depression, cyclonic storm, extremely severe cyclonic storm, etc. Now, this is how the cyclone warning division classifies the cyclone intensity based on the nomenclature given in the first column. Okay, and it is associated with wind speeds. Okay, so whenever a cyclonic storm is there, the wind speed, associated wind speed with that particular cyclonic storm can be between 34 to 47 knots. Unless the wind speed reaches 34 knots, it is not called as a cyclone. Okay. This is what is done at cyclone warning division. But based on what this is decided is based on the T number. This is the T number that we actually get by using Dirac technique. T stands for tropical because this technique applies only to the tropical cyclones. So this T is signifying that this is a tropical cyclone, and the T number is actually the intensity. Okay, so the intensity goes on increasing from 1 to 8, and the step is 0.5. So this table tells you that, okay, for example, if satellite is giving you T 2.0, what is the associated intensity? What you will call it? You will call it deep depression. And if you want to know what is the wind speed associated with it, then this is the 28 to 33 is the wind speed associated with this particular T number. Okay. Unless cyclone reaches T, unless a particular low intensity, low pressure reaches T 2.0, sorry, T 2.5, it is not called as a cyclonic storm. So at the genesis, when the low pressure starts to form and it reaches a particular intensity, it is called as T 1.0. Then it will increase slowly, and then finally, when it reaches 2.5, then only it is called as a tropical cyclone. Now, what this technique does is the technique relies on four distinct geophysical properties that relate to organized cloud patterns of the to the tropical cyclone intensity: vorticity, vertical wind shear, convection, and core temperature. Okay. So these are the four fundamental physical properties that based on which the tropical cyclone cloud organization will happen, and you will get information about what will be the intensity of that cyclone. Okay. So what is vorticity? Vorticity is the strength and distribution of cyclone winds. Okay. So higher the vorticity, higher is the intensity of the cyclone. What is vertical wind shear? Wind shear is difference between the wind speeds at winds at two different levels, so higher level and lower level. So the shear is kinematic force that acts to distort the vorticity. Okay, so if there is high vertical wind shear, it is bad for the vertical development of cyclone. Okay, and if the wind shear is low, then the cyclone is likely to intensify further. The only thing that will decide whether it will intensify or not intensify, but it is one of the things. After a cyclone reaches particular intensity, it is no more affected, not much affected by vertical wind shear. Only in the initial stages, when the cyclone is not very strong, that time it is affected by assignment. So convection, how the convection, that means clouds, how the clouds are distributed will define what is the type or what is the pattern of that particular cyclone. And higher the convection, higher will be the intensity. Higher the vorticity, higher will be the intensity. Higher the convection, higher will be the intensity. But vertical wind shear, higher the wind shear, lower will be the intensity of tropical cyclone. Okay, here it is inversely proportional. And finally, it is core temperature. Using cloud top temperature, whatever is available in satellite IR1 imagery, you will know what is the strength of the convection. If the clouds are very colder, that means the intensity of convection is very strong. Or if there is a eye pattern, how it looks like, I will show you. Then what is the temperature at the eye? Okay, eye is warmer compared to the clouds. Okay, so what is that temperature? So that also gives you idea about what is the intensity of cyclone. So this is how these four physical properties are indirectly taken care of when you are analyzing the satellite images. So whatever clouds identifying their patterns and everything, that all depends on these four physical parameters. So we are not measuring anything out of these four parameters. Only temperature we are measuring. Rest of the three indirectly we are taking care of. Okay. Now I will show you actual examples to start with, so it will be better for you to understand. It is getting closed abruptly. I don't know why it is happening. Okay, so on this page you can see on the left hand side is the visible imagery. There is a black portion at the middle surrounded by thick white clouds or bright clouds. Okay. This is called as eye pattern, right? This is called as eye because it resembles to the human eye. Black spot or dark spot and in the middle surrounded by thick white or bright clouds. Now why it is appearing dark in the middle? Because eye is actually a cloud free region, and whenever there is a cloud free region, what you will see? You will see the background black color because there is ocean below the clouds and ocean is appearing black or ocean is appearing dark. Okay, so this darkness is actually lack of clouds. Because of lack of clouds, because of cloud free region, you are actually able to see the ocean surface. That's why it is appearing dark and it is surrounded by very bright clouds. Similarly, in IR1 also you can see there is a small black spot in the middle surrounded by clouds. Okay, here you can see less number of clouds, here you are able to see more clouds. Both are from the same time, but left one is visible. And I have already told you many times that what is detected in visible, which clouds are detected in visible, and why IR1 is showing you more clouds. Because IR1 will also detect the cirrus clouds and cirrus outflow. So in IR1 you can see there are many cirrus clouds which are getting detected, and in visible cirrus is not getting detected. That's why it is appearing much clearer. And here you can see the cloud features very well in the visible channel compared to the IR1 channel. Okay, so basically what you need to say is this is how eye pattern looks like in the cyclone. There is eye surrounded by there is a dark spot surrounded by thick white clouds. Another example of eye. The eye can be very small. It may not be exactly in the center always of the surrounding clouds, and the thickness or the distance of this particular or the diameter of this particular black spot can change even for the same cyclones and for different cyclones. So eye diameter is not fixed. Okay. Now this is what is we call as eye pattern. Now what if this dark spot disappears? It also gets covered with clouds. how the image will look like. It will look like something like this. Okay, there is a circular cloud mass, and there is no dark spot or cloud free region at the middle of the this particular cloud mass. Again, another example of over Bay of Bengal. There is a very bright circular cloud mass, but there is no cloud free region at the center. Okay, here also the same. So when the center gets covered with cloud, it will appear like this without any dark spot in the middle. So this is what is called as CDO pattern, central dense overcast. That means the center is now overcast with clouds. Because of clouds, there is no, the center has covered with, the clouds have covered the center. Okay, so clouds have covered the center. Earlier the center was cloud free, now the center is covered with clouds. That's why there is no dark spot at the middle. This is what is called as central dense overcast. Oh, this is now not available. Okay, I tried to show you this in PDF file. Okay, on the left you can see this is a, now here the cloud mass was more or less circular, right? Here also it was more or less circular, but now here if you see, this is a comma shaped or curved band pattern. This is called as curved band pattern. Here, as the name suggests, there is a cloud band which is appearing curved, so it is called as curved band. Okay, the center is somewhere in this region and it is not covered by thick white clouds on all the sides. Rather, you are able to see that the band of cloud is curved. So whenever there is such a feature, that is called as curved band pattern. And the final one, this is shear pattern. Okay. Now what is shear? Again, the name itself is giving you information that the vertical wind shear associated with this cyclone is very high. That's why it is called a shear pattern. But how exactly it appears? So if you try to see here, the bright clouds are here close to the Tamil Nadu coast. But if you see this low level clouds, these are bright clouds, that means their height or the cloud top is at a higher level, right? These are very thick clouds. These are mostly CB clouds, very intense convective cloud mass, big cloud mass. But these clouds are low level clouds, and if you see these low level clouds, they are encircling and they are trying or they are encircling around a particular point in this region, but the cloud mass, intense cloud mass, is blown away from this region. So the circular cloud lines indicate where is the center of the cyclone. Okay, the circular low level cloud lines, always you need to look for low level clouds, not the high level clouds, because the center that we are trying to find out is at the lowest possible level, ideally at the sea surface level. Okay, so if you find this surrounding cloud, this circular clouds surrounding a particular region, encircling around a particular point, that is called as center of the cyclone, and the intense convective cloud mass is blown away from the center in a particular direction. This is because of very high vertical wind shear. So at the lower level, the center is on this side, but because of high vertical wind shear, the winds have blown away this particular thick clouds away from the center. So this is the most difficult pattern. This appears in the initial stages of cyclone. Okay. And once the cyclone gets intense enough, more than T3.5, then onwards you don't see this vertical wind shear. The cyclone becomes so strong that it is no more affected by the vertical wind shear in that particular region. Okay, but in the initial stages, most of the time it starts with the shear pattern, because the winds at the lower level and winds at the higher level, there is a difference between the two. And though the low level clouds are encircling at a particular region, the higher cloud mass gets blown away from the lower level circulation. This is how it appears. So even though the center will still be here, the Tamil Nadu coast would have already got or would have started experiencing very heavy rainfall, okay, because of this cloud mass. So many times it happens that the IMD will say that center is say 400 kilometers away or 200 or 500 kilometers away from the coast, but there would be already intense rainfall occurring over that particular region. This happens because the center is located away, but that does not mean the associated clouding is also only about or surrounding that region. The associated clouding may be blown away from that particular center. Okay. So you have to be very careful. You don't have to just look at where is the center of the cyclone whenever you are issuing any bulletins or whenever you are trying to understand any bulletins or alerts. Center is one of the important part of the bulletin, but center itself is not enough to describe everything. So a bulletin will always give you information about where is the associated clouds and what part of the actual coast or actual landmass is having very intense convection associated with the cyclone. Now we have seen what is the logic behind this particular technique, and indirectly it is giving or it is taking care of this four particular physical parameters like vorticity, wind shears, convection, and core temperature. Okay. Now this is the flowchart that you need to remember. This is the entire technique in a single slide. Okay. So four patterns that we have seen: eye pattern, curved band pattern, shear, that is vertical or shear pattern means higher vertical wind shear, and covered center is same as CDO, central dense overcast. Okay. So these are the four patterns. So if the patterns of cyclones are asked, you need to name these three and try to explain it, why it is called as eye pattern, why a particular pattern is called as curved band pattern, etc. Okay. So pattern and how they appear in the satellite imagery. Now you can see here there are different T numbers: data T number, model expected T number, and pattern adjusted model T number. Okay. So we will see what exactly is happening. This is just the introduction. In your syllabus, you have just the introduction to this technique. So whenever there is a cyclone, you start with this, and the first thing you have to find out is where is the center of the cyclone. Always the first step is finding out the center of the cyclone. Now once you find out center of the cyclone, you have to find out step 2 is what is the pattern of the cyclone. These are your pattern would be one of these four. Okay. And once you have center and once you have pattern, these two things, if you have, unless you have these two things, you cannot go ahead with the measurements. Okay. So center and pattern is what is required. Once you have that, there are different types of T number. First we will see what is data T number. Here again the name will tell you what is exactly getting done in this T number while we are calculating this data T number. Data is important in this particular T number. What do you mean by that is you are actually measuring the cloud system. You are doing some measurements on the cloud systems. How say for example, how much is the diameter of this particular cloud, or if it is eye pattern, what is the distance between the center of this particular that is say from eye to the outer edge of this cloud mass, what is the radius or what is the distance, minimum distance between these two, eye and the outer wall, etc. If you are doing such measurements, then or in case of shear pattern, you have to measure distance between the center and this cloud mass, edge of this cloud mass. So you have to do different types of measurements. If you are doing different types of measurements on cloud system and then you are arriving at a particular T number, then that is called as data T number. It includes cloud measurements using actual data. Okay, that's why it is called as data T number. So based on this measurement, you will get some T number. Okay, how exactly that is done? There is a table like this. Okay, visible analysis diagram. If you are using a visible image, then you have to follow these 10 steps. Okay, so to start, you have to locate the system center, and then you have to analyze what is the pattern. Okay, once you decide this two, there for curved band pattern, for shear pattern, for eye pattern, and for CDO pattern. Once you do this diameter measurement or distance measurement or curved band measurements, you will get a T number. For example, if you see, if you measure that for your particular case, this is the uh, distance, then for particular distance you will get a T number associated with it. This is like a lookup table that is given by Dvorak. Okay, based on analysis of hundreds of images, he has come up with this. Okay, so you have to come back to this table, do the measurements, and once you have these measurements, you will get a T number. So this is what is called as data T number. This is what is called as data T number because it includes some cloud measurements. Another T number is called as model expected T number. This model is not the numerical weather prediction model or simulation model. This is a simple model. Like this. Okay, this was the tropical cyclone development model proposed by Dvorak. So if you are able to see here from day 1 1.5, day 2 it is moving up to T 2.5, it is increasing by T 1.0 each day. So it starts with 1.5, then 2.5, 3.5, 4.5. So this is kind of ideal, or which is followed in many basins. The average T number increases per day by 1.0. Okay? So from if the T number on day 1 is T 1.5, on next day it will be 0.5, etc. So if your particular intensity is following higher than this, if your T number is increasing instead of 1 each day, if it is increasing by 1.5, then it is called as a rapid intensification of cyclone.
If you are using means you are
Or
strictly
if it
following.
is increasing only by 0.5 T number each day,
Entry
instead
means
of
you
1
have to
or
be
1.5, it is
here.
increasing only by
After
0.5,
when you are going
and it
to
is
do,
called as weak cyclone development. So that can give you an idea
yes,
even without any
we are
measurement
also doing
what
same
would be the T number
because
at a
we are
particular
following one thing,
time
right? We
distance.
follow daily.
So this technique is
That is
used
why.
to analyze satellite imagery every 3 hourly. So every 3 hourly the
Keep
satellite image is
entry exit
analyzed and you
biometric.
get a T number.
That are that you are strictly following
So
that.
you know
If you are
what is
not
the
following
T
in
number
another day, you will
yesterday
definitely ask why
at
you are
that
not
particular
keeping
say
that.
6 UTC
Exit
yesterday,
biometric.
say T number was
That is why
3.0.
randomly they
What
give.
would be the T number today at 6 UTC? So model expected T number, if the that particular cyclone is developing fast, developing rapidly, you would add 1.5 to the yesterday's T number. So that is a very crude model. There is no physics involved in this. You have to simply monitor and see the persistence. If the persistence is following rapid intensification or steady intensification or weak
Because I am
intensification,
going to
or if it is weakening,
you
okay,
come Pradap sir will come by
then
11.
it is weakening fast, it is weakening
After 2
rapidly
o'clock
or
you can
steadily
go.
or slow. all this
That is something
is
to learn, sir.
what is this called as model expected T number, that
only
what
1 2 class.
you are expecting
I
today,
wait for
what
the
T
evening.
number you are
Yes, I
expecting
like that
today
you talk.
based on the
Only class
history
four.
shown by this
They not
particular
like that and
cycle.
tell them.
Okay, in the last couple of days, in
Our
last
teacher is
couple of
always
days,
agree.
if T number is increasing by T
You will come
1.0,
back.
today also you
Exact,
expect
no,
that
do
it
that,
will
sir,
increase by
again go.
1.0. This is model expected T number. And the third T number is called as PT or pattern T.
He enjoying
What
the
is
life.
pattern T? Pattern T is, let's have a look at this particular diagram. What you need to do is manually you need to see whatever image you are currently analyzing, however that cyclone is appearing in your current satellite imagery,
Sir, I
whether
thought
it
to
is
ask you
INSAT
something.
based or it is meteosat or that is irrespective of that. In your satellite geostationary satellite imagery, how your cyclone is appearing, and you have to match that particular diagram or how it is appearing in your satellite image with one of these. Okay. So if, for example, your shape, current shape of your cyclone is matching
My
this
great mother
particular
has
thing,
some problem.
this particular shape,
Yes.
then your T number, pattern T number is T3.5. If your cyclone is looking like this, appearing like this in your satellite image, then that is PT5. That means pattern T 5.0. Okay. So simply it is pattern matching. That's why it is called as T number, pattern T
I could
number.
not come
Okay.
to at that time.
So here we were doing some cloud measurements. Here we were trying to go by persistence,
Your class also.
and here
At
we
what
are
time
trying
class
to
starts?
pattern match the
Then
cyclone with the table that he has given, okay, with different patterns that he has given.
okay.
So each one will give you one T number.
But I could not find the system and
Data T number, using data T number, you will have say T3.0.
Ah, he'll be sitting always.
Using model expected,
What is
you are getting
Nobody knows.
T3.5. And using pattern,
Paras also
you
will
are
be having
getting
it.
3.5.
even Saturday.
Then
No, no,
how
okay.
to
Saturday also is
finalize?
busy.
So this is done using best estimate. How
You
this
can
best
ask.
estimate is done?
Okay.
If your cloud measurements, if your cloud features are very well clear, they are you are able to observe the cloud features very well,
Okay.
and they are clear cut in your image, then you need to give more weightage to data T number. So you will finalize your T number based on data T number if you have confidence in your cloud system measurements. If for that particular time instance the cloud features are not well recognized in the satellite imagery, then
Night time it
you
is
need
free.
to give
You can come. That you do.
weightage,
Okay.
less
Anyhow, I'll
weightage
not
to
be.
data T number. Then
You come at
what you
5
will
o'clock.
do is
Anyhow, they'll
you
leave by
will go
6.
for pattern adjusted T number. Okay, pattern
This AC
adjusted.
also not working. How to survive today?
So
Very
like that,
difficult.
there are some
Yes,
estimates.
got frustrated.
There are some rules to choose whatever is the best estimate. Now, once you decided that your T number based on these based on these three T numbers,
Open the some
now the third one, if your pattern is also you are not able to pattern match. For example, your current pattern is not
We
matching
couldn't
any
sleep
of
yet.
this
Without
image,
AC,
any of this shape,
not at all
then
possible.
you have to give maximum weightage to the model expected T.
Well, I talked to
So
him.
when
Yes,
your
I
image
have
is not
one
clear,
table fan at home.
no
It's a new one.
confidence in cloud measurements,
Even if I bring this, it will not
you
use
need to go
properly.
for
That is why I
pattern T.
don't bring. But this time
Even
when
you
I
are not
come now,
getting any
I
shape
bring. But only
comparable
the
to
thing
this
is,
particular
we
diagram,
among ourselves,
then you need to go for model
we
expected.
need to long wire now from here
This
to
is how
outside.
you
We
choose
can
the best
keep that.
estimate. Once you
Inside
choose the
better
best
than
estimate,
keep
there is some
outside.
constraints.
Outside.
What are these
If you take that
constraints?
wire to
Constraints
outside,
are like
some
you
5 to 10
cannot
meters wide,
haphazardly increase the
then
T
what
number.
the junction box is there.
From T set T
That
2.0, T
table
number
one
can
we use.
increase to T
If table
2.5
we
only,
have
or
no,
it
then
can
we can
decrease to
easily save
1.5
night time.
only. So it can increase
This
either by
one it will not
0.5 or
work
decrease
for
by
AC too.
0.5. Okay. Every
Yes.
6 hourly it will
Huh?
increase generally by 0.5.
Yes.
Point
In our
0.5
room too.
increase or 0.5 decrease, or sometimes it can be steady.
wood. And night time,
It
I
will not happen
all
like
the
it
windows
is
open.
at
And while to
the T number is
Okay.
2.5
room is
and
12
T
p.m.
at 6 UTC.
Okay.
However, from T 2.5, the cyclone is showing T number
Fine.
as
After 2 to 3 a.m., I used to stop my fan
Fan too.
so.
because it's so much cold.
Okay,
Similarly,
then it's
at
fine.
night time, we have
The day
started
before
from
yesterday,
0
I slept
UTC.
outside only by
After
putting that cart
after
outside.
say
That
12
time,
15
wind
hours,
was good.
now you are at
Minimum
night
5
time,
to 10 knots. And
and at
no
night
problem.
time, the
First,
visible image is not to do all
we
this
can sleep
measurement based
easily
on
with if there are no
so
mosquitoes outside.
initial
Mind you,
cyclone
it says some
development
mosquito,
stages,
but I put some
what is
window net.
T number is not lower
That's
than
fine.
time. That means before night final visible image you got T at 2.0. You finalize is 2.0, and after that for
So when I am in office,
image
I always
you are
use
relying
my
on the
normal
IR1 image, then are not supposed to lower the T 2.0 to 1.0
pressure cookers.
till
Nah,
first 48 hours of
inside.
cyclone.
Actually,
Why?
I personally block
Because of
2 to 3
that
times.
variation, the
We need to
cloud
share,
pattern
then no
that
problem.
appears during day and at that appears during
Where
night
is
will
everybody
change.
using it, no?
Sailing,
When you are on duty?
sailing is good because
Yes.
The
all are
cyclone
using
is
the
in the
other
initial
Yes.
stages. The diurnal
It is
variation
better.
of
That
the atmosphere
milk
will
then remaining
the
steel, everything
cyclone
bought for
pattern
myself
the
with my own
cloud.
money. Even for that
We
cooker
are
also, they
all
all
doing what
give
we are
some
doing.
100 to 100. I then
Shade or cloud
some 950 that
cloud
everybody gave
measurements.
some 600 like
So
that.
if the diurnal
150 like
variation
that.
is
So
affecting
money.
the
Remaining 350 I myself spend. Because
during
I don't
first
care
48
about
because
that is but every
the
time spending
cyclone
same
is
amount
weaker,
is very
then
difficult.
only this will happen.
it's
For first
but only
48
one
hours,
person,
the
not
cyclone
good.
T number is not lower than night.
If also now also I can bring
Then
that fan because keeping
increase or
idea
decrease
at
can happen
home I am
by
not using that because
0.5.
we have three phones, three
Rules like
fans,
this,
ceiling fans.
these
I'm not
rules
using
are
the
the
table.
best estimate.
Earlier
You apply
when I
this
was here in
and then
Tirupati,
you come up with the
I was in another
intensity
room. That time I bought it.
FT
New one.
or
Everything is perfect.
T number.
I can bring, but that table also they are not interested. And who is else can help
So
them?
try to remember whatever
At
I
least
told
they need
you
to share,
around
no?
this particular
But table it will, I think, some,
like that
I don't know, some 10 meters wire it may be around 300, 400.
T
For
numbers,
1 month,
what
each
are different
150.
patterns,
Not
how
10 meter wire.
you choose the best
No,
estimate,
no, outside there
then some
we can keep. Outside.
fine or you come
10
up
meter,
with
20 meter wire,
the
not a
intensity.
400 one, it's too much.
Yes.
Maximum 200 maximum.
Yes. What's
150.
called junction box, right?
Now all requires lot of
So it's not junction box. Why?
straightforward, not very straightforward. That is technique that you will be able to see. Many a times or the cloud features are so complex that it becomes really hard, especially at night time because IR1 channel only is available. Channel it becomes difficult. So let's see what are the limitations associated with Dvorak technique. The limitations associated is Dvorak technique is not using any direct measurement of wind, pressure, or other quantity. We are not utilizing any wind product, any vorticity, convergence, divergence, any dynamical product we are not using. What we are doing,
This one box like thing, some 300, 400
Yeah,
junction box.
yeah.
But the wire not 1 to 2 meter maximum.
No, online now it is available.
But wire length not 1 to 2 meter maximum.
When I seen that video, I saw only one
There,
video.
there are
Diameters.
I got it.
charging everything.
Then I thought, okay,
Some 8
maybe
what is
something
the
happened,
cyclone
so
wind
they
intensity of
posted
cyclone.
it.
That may vary based on the analyst
talk to
interpretation.
him.
That's why experience is required to analyze it in a
And
better way.
No, he's going
Borat
Today,
has
after coming here,
expressed his views
sir,
that analysis of weak system is more
immediately
complex
told
and
him,
more subjective.
please repair this AC.
When the
This
T
is,
number
this
is
is
less
not,
than
we cannot
2.5,
sleep
then
without
we are
AC
not calling it
in
as
this room.
cyclone. When it is simply
Then
a depression or deep
asking for
depression or
some,
low pressure area, that time the
Naresh is asking
intensity
for
of
some,
cyclone, because it is
for
very
by
low,
calling
Okay.
some
the
technician
cloud
number
features are
on
not
the
well
EPG.
organized. The cloud feature gets oriented or aligned or very well
I
organized
think some
once
3-4
the
points
cyclone is very
better.
intense. Okay. So you have more confidence in the cloud measurements when the cyclone is more intense. When the cyclone is very weak, because the clouds are not very well organized, you have low confidence, and that's why he has expressed his views that analysis of weak system is more complex and more subjective. These weak systems are also more prone to diurnal and non-periodic oscillations. Okay, that's why during first 24 hours or 48 hours, the T number is not low. The technique is physically
10
restricted due to
meters
natural
with length,
variability.
maybe
Okay, you
from
can
how much
30
limit
to
it.
foot,
there?
30
Final
foot,
one and the most important limiting
30
factor
feet,
of the
that's it.
technique is
maybe this from this,
dependence on the
I think.
That's
IR
all?
imagery at
Total.
night time,
This corner
in which
till this corner,
cirrus clouds
That
can
is enough.
obscure the TC
How much length will be
organization.
there? 10 meters.
So you are
maybe
trying to measure
30
the cloud
feet.
features,
You can
but
imagine.
because of cirrus,
And
you are not getting very well
I think this
low or
from
medium
this.
clouds. It is
Because
getting
I am
obscured
sleeping
because
towards
of
that
presence of cirrus cloud
and rack is
during
there
night time.
outside. Grill is there,
So
no?
it is the most
Near grill
limiting
only I
factor
will
that
sleep because
at night time
lighting will be
IR
there from
imagery,
outside. With a
because it
small light
detects
also I
cirrus,
cannot sleep. That's the
it is
problem.
not
Okay,
easy
I'll
to
use this
figure
what
out
bedsheet and all
exactly what are
to
the
cover
cloud
that
features, and your
total
measurements may
length
go
of part,
wrong slightly.
not to obstruct that light to
So this
directly,
is also one of the
and then I'll sleep.
important limitation of the Dvorak technique.
There's some wire, 1 meter, 2 meter
So
wire
this was
also with the
introduction
fan.
to Dvorak technique.
Yes. But 10
I
meters
have
is not
finished the
good.
syllabus here.
I'll talk to them because it, anyhow, even if you repair,
If you have any
I
doubts, you can ask me now.
let it get repaired. I am not sure. Yes, there are so many ACs gone.
What?
They are working on it. Whether
All
they
right.
come or not here, I don't know. Today, how to survive?
Very difficult.
Outside only, most probably I'll sleep. I'll pour water
If
the
there are
ground
no doubts, I will stop the
outside
lecture here.
Hmm.
Thank you.
some 8, 10 o'clock. I'll try to sleep.
Thank you, sir.
Definitely, day after tomorrow I'll
Thank you, sir.
bring.
Thank you, sir. थैंक यू तो बोल देना चाहिए.
Yes.